just going to talk a little bit about how acids and bases are in our lives. And then what we'll do is we'll do a little bit of work on going back to what we had done in the beginning with naming acids and bases, and then we're going to start doing some calculations. So acids and bases play a central role in the chemistry that affects our daily lives. Our bodies need the acids and bases to function properly. And so there are certain levels that our stomach, for example, anybody know what pH the stomach and our acids in our stomach are at?
7.
It's low. And we're going to talk about what this pH value means in a little bit. It's actually closer to 2.73. They say that it ranges. And whether you've eaten or not, it also there's a range, okay? So the pH of human blood is actually at 7.4. The kidneys and the lungs have to work together to try to make sure that your pH stays at that level also. If you have just any slight difference in that, then that can cause death. Acids and bases are also important in manufacturing, like sulfuric acid is used to make fertilizers. Sulfuric acid is also in a type of battery. Anybody know what kind of battery?
Car battery.
Yeah, the car batteries are like if you have a boat or a Sea-Doo, like a jet ski, something like that. A motorcycle, those are the batteries. That's the acid that's inside of there. So it's also used in making polymers, which are chains of chemicals and other materials. And we're also acid rain. We will do a reading on acid rain that affects surface waters, aquatic animals, forests, different materials, our visibility, and just human health in general. And then we're going to think about some other acids and bases that play a role, like some acids, types of acids that you eat, a lot of us, on citrus. More like citrus, perfect. And citrus fruits have what kind of acid in them? Citric acid. Let me change my color here. Citric acid. And the formula for it is C6H8O7. Vitamin C, this starts with an A. Most people have never heard of this one before. Anybody want to guess? AS something? I feel like you heard ascorbic. Nice. That's called ascorbic acid. So for example, tomatoes would have ascorbic acid. Look at the difference between citric and ascorbic. What's the only difference in the chemical formula? One oxygen. That's it. The ascorbic just has one less oxygen than the citric acid does. Lemon juice is around 2.2, that's citric acid. Tomatoes are around 4.1. Sodas also have acid in them. Anybody know what kind of acids? 2. Carbonic, nice. And phosphoric, awesome. Carbonic acid. And so carbonic acid and phosphoric acid. Tea. It's the color of tea. I got some very interesting colors earlier today when I said this. It starts with a T, and it's the color of tea. It's not teal. Tan. You said tan?
Yeah.
Tan. Nice. It's called tannic acid. It's called tannic acid. Teal is actually more of like a bluish color. Vinegar. We use this at the beginning of the year. Anybody know what vinegars is? Acetic. Nice. And that comes from acetate, so acetic acid. And then the electrolyte we already talked about, like in the car battery. Chlorine to clean a pool. This is called muriatic acid, is what they call it. It's mostly just hydrochloric that's inside of there. All right, examples of bases. So we've got mortar. Where's mortar used?
Bricks.
Bricks, laying bricks. Awesome. Calcium hydroxide is what they use in mortar. And for bases, acids start with an H. Bases end with hydroxide with OH. Antacid tablets. Now there are different things that can go into antacid tablets, but one of the major components, the first part of it, is a metal that we ingest all the time. It's the same thing that's in salt. Sodium. So Na, sodium, but it's not hydroxide. That would be, that is in cleaners, like oven cleaners and things like that, might have a strong sodium hydroxide in there. It's Na something. Typically the bases end in OH, okay? But there are different definitions for acids and bases that we'll talk about later. So the second part of it is an ion that floats through our bodies, and it starts with an H, so it's a bi something. Anybody remember the polyatomic ion? Bicarbonates. Awesome. So do you remember what the formula is for bicarbonate? HCO3. Carbonate had a -2, so bicarbonate is a -1. So it's +1, -1, so it's just NaHCO3. And that's a major compound in there. So how does it work? Because that looks funny. It's like, why is that an antacid? So you have acid in your stomach, right? And if there's too much and it causes heartburn, right, or something like that, then you have extra H+ ions that are floating around in your stomach. So this breaks apart. The Na breaks apart. Remember when we did ionic equations? The Na breaks apart and the HCO3 breaks apart. Well, the HCO3 will actually grab onto what? The hydrogens, the H+. And then you're thinking, wait, that doesn't sound right, because that sounds like it's making it more acidic. But H2CO3, or carbonic acid, does not stay as carbonic acid. We talked about this earlier in the year. In your blood, it's in equilibrium with two other things that actually, one of which will form a gas. Anybody know what H2CO3 breaks up into?
Carbon dioxide and water.
Nice. Oh, so smart. CO2 and H2O. Guess what you do with the CO2?
You breathe out.
Yes, you burp it out. Maybe it comes out the other way, but yeah, you've got gas now, okay? You've created gas and then just water that's left behind. So that's how the antacid basically works. Household cleaning agents. So what bases in household cleaning agents? How many of you, or you've probably used some different things before, like?
Windex.
Bleach, awesome. Windex. What's in Windex is the ammonia in Windex. So the ammonia in the Windex. Soaps are also going to be basic. Okay, so these are the basic ones. These were the acidic. Acids and bases, if you mix the two together, you will actually get, anybody know what you get?
Neutralization.
A neutralization. So what's a neutral solution that you know? Water. And what's left behind, typically, is called salt. Awesome. Now, it may not be NaCl, but it could be something like MgCl2 or NaF. So it can be anything that has the metal with like one of those halides, typically, okay, with a negative charge. And a way to remember it is I always just think of these two guys who go into your local deli and their names are Walter and Saul. Walter and Saul sit down to have some matzo ball soup. Okay. Something to note, remember to do as you oughta, add the acid to the nice. Do as you oughta, add the acid to the water. And so if you're working in lab, unless it's a dilute acid solution, then it won't really make a difference. But typically you always want to add the acid to the water instead of the water to the acid. Otherwise what ends up happening is it gets really hot too. It's an exothermic reaction and it picks up the acid before it's actually dissolved inside and reacted. And it gets in the air. And so it can be really dangerous. Okay, names. So everybody say this with me. It's H to the acid, OH to the base. Go. No. H to the acid, OH to the base. The second part is always keep your goggles on, safety for the face. So we're going to do, if it starts with an H, that's an acid. If it ends with a hydroxide, that's a base. So an acid is a compound that produces hydrogen ions by definition when it's dissolved in water. That's one of the definitions. So there are others, okay? But this is the one that we're going to use in this class. It's usually seen as H with an X minus, where H plus is just your hydrogen ion. And what do you call the negative? If the positive's called the cation, the negative's called the anion. Good. So this is whatever anion that you have. So something with a negative charge. So what this table basically shows is that hide Titus in the adic. So we're just going to write it right here. So remember it was hide tight us. I'm just going to write it changes to us, and 8 changes to ic. Okay, now let's try these. So the first one is H2S. Remember, the way that this works is if there's no polyatomic ion in it, then it starts with hydro. Otherwise, you're not using any hydro, okay? So this one you would call, no polyatomic ion, you would call this Hydro, what do you think this is? Sulfuric. And it starts with an H, which makes it an acid. Awesome. These two both have polyatomic ions in them. One's an 8, one's an 8. The one that has an 8 has one extra oxygen. Remember, it was an easy way to remember it to say, after I ate, I gained an oxygen. So 8 has an extra oxygen. So then that means that this is sulfate, and this one's sulfite. So what would you change the ite to? Ite changes to us, but it's not sulfus, it's sulfurous. Awesome. So that one's sulfurous acid, and then this one would be sulfuric acid. Okay, let's try these now. This is going backwards. Remember, you have to crisscross your charges when you go backwards. Since these all are acids, they all must begin with what? H. Good. So write your H's in. H plus for all 5 of these. Okay, the first one is hydro. So if it's hydro, that means no polyatomic ion. So on this one, there's no poly ion. Okay? Only that one. Unless it was cyanide, cyanide was the only one that would fit in that one. So if it's hydrochloric, then that would be HCl. And Cl is a negative charge, so that works. We don't have to cross anything. This is not hydro like this one was. This is hypochlor. So us is going to change to ite. So this is changing to ite. So we're thinking about hypochlorite. It's been a long time since we looked at polyatomic ions. What's hypochlorite? It's not Cl. Cl. Oh, perfect. HClO, just one oxygen. So then this one, chlorus, we just changed to ite. So chlorite, instead of having one oxygen, now has 2. So this one's ClO2. Then chloric changes to 8, so that one would be ClO3. Very good. And perchloric, remember perchlorate? ClO4. Awesome. Okay. If these did have a charge, you would crisscross it down. Bases are really easy. Remember, when you name a base, it's the same thing as naming any ionic compound. The only thing is that it has hydroxide at the end. So you're going to name it whatever the cation is, your metal or your cation, and then it's going to end with hydroxide. Your hydroxide has a negative charge. So whatever your cation is with hydroxide. So let's try these. HF, no polyatomic ion. How do you start it? Hydro. What do you think? Fluoric. And then it starts with a hydrogen, so it must be an acid. Awesome. Let's go to the right and do B. K is what? This is not an acid, right? Because it doesn't start with an H. That's going to be a base. So potassium, and then how do you end it? Hydroxide. Awesome. Potassium hydroxide. Okay, C. HNO3. Okay, we didn't do any polyatomic ion. We didn't do NO4. So that means that NO3 is the highest one. If NO3 is the highest, then it must be nitrates. Very good. So nitrate, you would change to nitric. Good. So 8 changes to ic, if you remember attic. Next one. This is a hydroxide, so we're doing a base now. What's Ca? Calcium, and OH is?
Are we going down now?
Oh, sorry. Yeah, or we'll go to the side after. Hydroxide, very good. Let's go to the side. Sorry, I meant to do D, not. Okay, the next one's H2SO4. So now we've got SO4. You've never seen SO5, which makes SO4. Okay, so then in this one it would be if it's sulfate, then it's sulfuric. Perfect. Acid. Awesome. And then PO3. Have you seen PO4?
Yes.
Yes. So then if PO4, if there is a PO4, then PO3 is probably phosphites. Good. So that's the ite version, so you would call that phosphorus. Acid. Okay, let's try to go backwards. So now we've got chromic acid. So that comes from, ic comes from 8. Good, so chromate. CR, it's, we know it's an acid, so it's going to start with an H. It's CRO, it's 24s. I did the chrome wheels, riding on 24s is how we said it. So it's a -2 charge and a 4 down there. So what do I do now? That's not done. CrH2CrO4. Perfect. Let's go across here. Hydroiodic acid. Again, if it's an acid, just put an H in front. So I'm just going to do that so I don't forget. So there's an acid, and then there's one more. So hydro means no polyatomic ion. So what would that one be? HI. Awesome. Okay, let's do C, iron 2 hydroxide. Do you remember what this Roman numeral means?
What charge is it?
The charge, good. So it's Fe with a 2, and hydroxide we said was OH with a -1, so that's FeOH 2. Awesome. Lithium hydroxide. So lithium Li is in the first column here. It's in the first group or the first family. That has a +1 charge, and hydroxide is OH minus. So don't have to crisscross. They cancel out. LiOH. Okay, how about nitrous? That changes to ite, nitrite. NO2, awesome. So NO2 is a -1 charge. There's one moon at night. So NO2 with the -1. And the last one is hydrosulfuric. Again, the hydro means no polyatomic ion, so that would just be S. But S has a -2 charge. So it's H2S. Why? You're thinking, I don't know why she's saying that it has a 2 charge. Remember, the noble gases are 0. The next period over are the halogens. Those are -1. Then under oxygen, like sulfur is, are -2. So it goes 0, -1, -2. All right, and that's the review of